Hi everyone, good morning.
Good morning.
All right. I hope you can see my screen, right?
Yes.
One of you please confirm.
Yes.
Okay, fine. Thank you. So in our last class, we went through some of the basics around routing. Okay. What is routing table? What is forwarding table? How they are populated? What are the different sources of routing information? Okay. And like forwarding table, Cisco Express forwarding. We also configured static routing within our lab. So anybody have any questions so far what we have read? Any questions from anyone? Oh, okay, no worries. So let's move further, and today we'll start our class with this DHCP for IPv4 protocol, dynamic host configuration protocol. This will start today. And, before we start this one, can anyone tell me what is DHCP protocol? Anybody has any idea? Have they used it ever? Anyone?
Using DHCP, we can assign IP to system automatically. So it runs on the principle of Dora, discover, offer, and request and acknowledgement.
Very nice. So you said DHCP for automatic address assignment, right? Automatic address assignment, and you said discover, offer, request, and acknowledgement. These are the 4 different things that you can find in DHCP protocol. Anything else from anybody?
To save private IP addresses, we create a pool from where it will assign dynamically to users IP addresses.
Saving addresses, huh? Okay. Anything else? Anybody? Okay, no worries. So these all things what you have told, these are perfectly correct. I mean, you are right that this is the full form is dynamic host configuration protocol. Okay, this stands for DHCP. Now you said that it is used for automatic address assignment. Okay, one thing is this one. So second thing is we need to define a pool of IP addresses. So I can say that it works in a client server model. Okay, where one of your device will act as a DHCP server who will serve your clients to provide IP address and other information to it. Okay, and the client will be the one who will be requesting from the DHCP server. Right. Third thing, we can say that this discover, offer, request, and acknowledgement. These are the 4 packets. We can also call it as an acronym of Dora. Okay, this is just a short form for all these 4 messages being exchanged between your client and the server. We'll go through in detail what each message means. Okay, next, it provides your IP addresses. What else apart from IP addresses? It can send you a default gateway information also. It can send you a DNS information. Okay, or what else? It can send you information about any TFTP server or any other voice related things in the form of options, DHCP options, right? Can you give me any example where this you might have seen? It's in your day-to-day life where you have seen this client server model of DHCP.
In access point, sir.
In access points. Okay,
For
you mean wireless network connectivity, right?
For
Yes.
telephones, VoIP,
Sorry,
for telephones, IP phones.
IP phones. Okay. Anything else?
Home router,
Sorry,
home routers.
home devices. Very well. Very nice. Home broadband router acts as our
Yeah, others.
DHCP server, right? And your workstations or your mobile phones or your
Mobile or laptop.
they
This.
act as your client, right? This is a very common example, right? Next is you must have used your phone as a what is called that
Mobile hotspot.
data sharing hotspot. Yes, very nice. Okay, there also what happens is your mobile starts working as a DHCP server, and your other mobiles or your laptop who is sharing that connection, they becomes as a client, right? That's how it happens. You need not to give or specify the IP address to your client machines all the time. I mean, it's most of the time, I would say 99% of 90% of the time, we usually nowadays have our machines which we are using in our home, may it be your laptop, may it be your mobile, may it be your this one, your LED TVs, smart TVs. Okay, they are also being consuming your internet connections. So there also you need not to enter any IP address. They acquire it from your DHCP server itself. Okay, and your broadband router is acting as a DHCP server. So these are the common examples. Within, yes, somebody said the Wi-Fi connectivity. So it's also an example of your Wi-Fi connectivity. Wi-Fi or wireless is just a transmission. Okay, rather than using an Ethernet cable or a wired medium, you are using a wireless. On top of that, I mean, this is a service that you are running, DHCP, right? Any questions from anybody till now?
Yeah, sir, Nitin here.
Yes, please.
Yeah, sir, actually I joined late. So today's first day.
Now, today is our third class. In our first class, we went through what will be, the demo for this Enarsi and Encore course. Okay, in the second class, we went through the basics of IP routing, static
Okay.
routing, administrative distance. I mean, this is the third class.
But sir, your team side, I have got invite today. Today's first class for CCNP and RC.
It's almost first class. I'm saying this is third class.
Okay.
I'm not aware to whom you have spoken, but I think we can discuss this in the end of this class, Nitin, if you allow me.
So right now you are learning at DHCP, right?
Yeah, this is the first chapter we are going through. Only the basics
Okay.
were
Above is
covered in the
IPv4 addressing
last
or
class.
fundamental
Correct. Yeah,
foundation?
static routing and routing information sources that we covered in our last class.
No. Sir, sir, can I ask your name, please? Good name, please.
Gaurav.
Okay, Guru, sir. Thank you so much.
Okay. Thank you. So these are the 4 messages that we cover. Okay. So this DHCP client, first message is always sent from your DHCP client. This we may call it my lap. Sorry. So this is, let's say, my laptop machine. Okay. And this is your broadband router, who is acting as DHCP server. So first message, it is sent by your DHCP client, who is sending a DHCP discover message. Okay. This discover message is being sent to your server, and it is being broadcasted. Okay, because I do not know who is my DHCP server, or who is acting as a DHCP server in my local network. Okay, because till now this DHCP client does not have any IP address, so I do not know. So that's why this message is being sent as a broadcast. Now again, in response to this discover message, your DHCP server is sending this DHCP offer. So within that offer message, it is offering you an IP address to this client. Okay, but this offer message is also sent as a broadcast message, because this does not know who is the, who is the receiver. Till now, it does not have that IP address. Guys, may I please request all of you to join on time next time? Okay, thank you. Okay. Next is your DHCP request message. So request is, okay, this client has accepted that offer and it is sending a request. Okay, please allocate this address against my name. Okay, this is being sent towards your DHCP server. And finally, your server is sending as an acknowledgement, okay, I have reserved this IP address against your name. Okay, this is known as Dora process. First message, discover, offer. Okay, next is request, and the 4th one is acknowledgement. So if you see the details also, what it is sending is DHCP client initially boots. Okay, therefore it is sending a DHCP discover message. Destination IP address, broadcast. Okay, destination map is also being broadcast. Since we do not know who is acting as a DHCP server, there may be multiple machines over here, but who is acting as a DHCP server, you are not aware. That's why it is being sent as a broadcast. Next, your DHCP server upon, still people are joining. Okay. So in response to this DHCP discover message, your server is sending, responding with a DHCP offer message. Okay. DHCP client communicates with the selected server. Why this offer is also being sent? Can you understand? Like on this here itself, I may have another server. Let's say this is also a DHCP server. Okay, I may have more than one DHCP server. So this discover message is being sent to both the servers, and let's say both are replying. Okay, so the client will choose one of them, and it will be sending a DHCP request message to only one of the servers, not to the other server. And that's where it will be acknowledged. All right. DHCP offer. In response to this offer message, your client is sending a DHCP request message indicating that it will be using this address provided in the offer. Okay, and I want to associate this address. Please lease me out. And finally, your DHCP server is responding to the client with an acknowledgement message, indicating that IP address is leased to the client and includes any additional DHCP option. So these additional options means, I mean, you can provide your DHCP server address, your default gateway, any DNS address you want to advertise, that all will be sent towards your client. All right. So another concept, any questions from anybody till now? No. Okay. So as I said that this discover message and other messages, they are being sent as a broadcast. Okay. If there would have been any router in between and I'm sending a broadcast message, can this router relay or pass this as a broadcast? Is it possible?
No.
It's not possible, right? So that means in order to work, I mean in order for this DHCP protocol to work, my client and my server, they should be in a single broadcast domain or a single LAN, VLAN. Correct? Because otherwise, if any router is coming in between, he will not be able to forward my broadcast packet. Now, this is a question. It may happen that my host or the client who wants to receive a DHCP address and this server, they are several hops apart, or they are, I mean, in my complete enterprise network, from one router I have connected this DHCP server, and there are so many routers or switches, layer 3 domains via which our hosts are connected. This is host 3, let's say host 2, they are connected like this. But this is a centralized server, DHCP server, which is connected within my enterprise network. This situation may occur. So how will we address this concern? Because see, understand the problem is your DHCP packets are being sent as a broadcast. Okay, and the broadcast packet cannot go beyond your layer 2 domain. This is the problem statement. Now, what we can do is, what we can configure is, we can on our first hop router itself. Okay, let's say this is our router, or if I just delete this all. Okay, and let's say this is one router, and this is another router in between. That's how they are connected. Router 1, router 2. This is sending a broadcast packet. So on this first hop router itself, since I cannot pass this broadcast message, so can I pass this as a unicast message? That is possible. So this concept of receiving a broadcast and relaying it as a unicast, I mean, this is known as configuring a DHCP relay. Okay, so this where it will help us when our DHCP server is not in the same layer 2 domain. I hope every one of you understand this, what I'm saying as a layer 2 domain.
Yes.
Okay, so what this on this router, on this first hop router itself, and this interface itself, on this interface itself, I need to configure a DHCP relay. So this configuration of DHCP relay, what it says is, what all packets I'll receive as a broadcast, DHCP broadcast packet I will receive over here, I'll convert them as a unicast and will send it towards this DHCP server, to whom I should have a route. I should have a reachability. via any means, may it be via static routing. Okay, by any means I should have a route in my routing table. Okay, that is known as DHCP relay. Any questions till now, or we can move to our lab section. So these are some of the other things that you can receive from your DHCP server. It can tell you what is your DNS server address. It can tell you what is your time service address, netbus server name, okay, TFTP server name. So from your DHCP server itself, you receive all this information. Okay. Open. Here, how we are doing this device. Let's say on this router, we have configured it as a DHCP server. I will show you what configuration over there. However, this link between R3 and this DHCP server, this is using this IP address range. I usually configure this. I mean, the first two octets I keep 192.168, and the next octet C I keep first router as a lower router number of the connecting link, and the other router as a higher router number. Okay, here I have taken R3 as 3 and the 4 as this one. Okay, 34.24, and this interface would have been .3 and this interface would have been .4. Similarly, over here between R2 and R3, 192.168.23. This is the same address convention you will find in our almost every lab. Okay, this interface would be having .2 and this interface would be having .3 IP address. Similarly, this is layer 2 domain. It's a pure layer 2 switch where we have connected two other routers. They'll purely act as your host machines. Okay, IP address on this E0 by 0 will be configuring via DHCP. Similarly over here, 12.0 network over here, and on this interface .2 has been configured. So let me power on these devices and I'll show you.
Sir, meanwhile it is turning on. Can you just share the book with the networkings? Because last day, I mean yesterday, I was asking him. He told that they didn't share. I mean, that's what they came back to me, that I need to check the trailer.
I'll reconfirm, but definitely I send it.
No, actually, it was supposed to be in the resources section. When I spoke to the networkings last week, they said you were supposed to upload it. They don't know anything about it, actually.
That's right. That's what.
No,
that's what they can.
No, guys, I think there is some confusion. I don't have any access to the portals. Only they can upload it.
Just
But
ask them to put it in the resource section. Actually, that's where usually anything will be there.
I'll definitely ask them. But meanwhile, what I can tell you is you can search it on Enarsi official cert guide on the Google. Definitely, you'll be able to find out.
I couldn't get a downloadable version. Actually, I checked it. I got it for Encore, but I couldn't get the Enarsi.
Okay, no worries. I'll reconfirm with them because the same day itself I send them. It's only them who need to upload in the folder. To whom did you spoke? Pradeep or Gaurav Sharma?
It's actually the support email address that we have for contact.
Okay.
So we emailed them,
I'll
and
reach
I actually managed to get the lab access. But when I asked for the and also, sir, you need to tell me where is the lab? I mean, the location that you're trying to open.
This lab I'll tell you. I mean, once I will go through it, I'll upload into the networkings folder. So I'll open that. Okay. Do I have? No, I don't have. Wait a minute.
Sir, is it the first class or I missed the one?
You missed a lot, man. We discussed this in our today's class also, that this is our third class. Guys, please join on time, otherwise you will be missing a lot. So this is, I hope you will be having access to this one. This is event of networkings. Okay. In this
Yes.
one, there is this one folder, Gora_NRC. I'll be uploading this labs over here. This is already here, DHCP relay. This is the same lab which I'm showing you. You can find it over here. It does have its startup configs also. All right.
Sir, can you please?
Okay, thank you,
Can
sir.
you please?
Yes.
Yeah, sir. Can you please back your window? So how to access your folder, Gora or something?
Okay. If I close this lab, this is the root. Current position is root. Okay. Here itself, you will find this folder.
So
If I-
it's our portal.
I'm not aware if it is your portal, but I assume that you will be having access to this
You can ask
event
the
server.
support. Yeah, support team will send you the link. They will
Okay,
provide you
okay.
the access.
Okay,
Yeah,
okay.
they need to provide the access to this one. Huh?
Yes.
Yeah, okay.
Right.
Thank you. Okay, thank you.
Okay, close this one. Go back to our usual one. Okay. So, oops.
So, what is the topic of okay.
Sorry. Was there a question? Okay. So let me first show you what is there at DHCP server. Yes. Question?
No, sir.
Oh, let me remove this configuration. Then it will be better.
So we are seeing a running config at this time.
Yeah, you are seeing running configure. Correct. Let me just remove this. Okay, this one I have removed. Now, coming to this R2. Let us see what is the configuration at R2. So on these two interfaces, E0 by 0 and E0 by 1, we have configured this as an IP address. Which protocol are we running? Show IP protocols. That's how we can see. Right. So this is your OSPF protocol running for these two networks. Right. Area 0. So to make the reachability between all these devices. I mean, let's say from R2 till DHCP server, you need a reachability. So we are running OSPF as our routing protocol. So in our routing table, if you check show IP route, I have a route to this network 192.168.23.0. 23 is this one, and I should also have a route for 34.0. 34 is between R3 and this DHCP server, right? I'm learning this via OSPF. Okay, what is the default AD value for OSPF? 110, right? This we saw in our last class also. Although we have not studied the details about OSPF, but this thing you should be aware. How to check your routing table. I mean, how can I ensure that R2 and this DHCP server, they are reachable to each other. They are exchanging the routes. Now, similarly, at DHCP server, coming to DHCP server, you can check your routing table, show IP route. See, this is having a default route, static default route. Okay, or via show IP protocols, you can check which all routing protocols I'm running. Okay, I'm not running any dynamic routing protocol over here. Otherwise, it will show you. So using this default route pointing toward 34.3. So this reverse traffic. If you see all the reverse traffic is using the default route. And from R2, R3, I'm using OSPF. Okay, in order to learn. You can check from your devices also from R2. So I can say brief. If you just ping this 34.4, you can give a source IP of 192.168.12.2. Oh, sorry, not from DHCP server. It should be from R2 from here. One six eight 34.4 source IP 192.168.12.2. This is reachable. Okay, so our objective is for these two hosts, host 1 and host 2. For host 1 and host 2, you want to receive or configure their IP address via DHCP. Via DHCP, you want to get the IP address. So let me quickly show you what has been configured at host 1 or host 2. So in order to configure a router interface to achieve IP address via DHCP, or in order to configure it as a DHCP client, this is the command that you need to configure. IP address in DHCP. Okay, if I show you over here, IP address. So either you can configure as an, I mean, statically IP address that you can configure, or you can configure that I want to acquire or I want to negotiate via DHCP. That's how you can configure, right? So right now I have configured this as a DHCP client. Okay, and let us see if it is generating any packets over here. If I go back, show IP interface brief. Here also, right now it has got an IP address since we powered them on earlier, and later on we removed this DHCP pool configuration over here. So what we can do is, let's shut on this interface to remove this IP address. Shut. Okay, and if you do a no shut, it should remove your IP address. showing unassigned. Method is DHCP. Otherwise, it would have been a manual over here. Status is showing up that we saw in our last class also. Now, if I just try to capture the packets on R2 E0 by 0. And let us see what all packets we are receiving. Filter the DHCP. Can you see this DHCP discover message I am receiving? Okay. So these packets where we are capturing at this particular interface. Okay.
E0/0, right?
E0/0 of R2.
R2 from R2.
Yeah. Now, if you see, I'm continuously getting DHCP discover message only. Okay. And see, in your first message, can you see the source IP 0000, destination
Default.
IP 255.255?
So it's the default, right?
No, it's not default. It says that my host does not have any IP address.
Okay.
It's not a route. It's not a route. Okay, it does not have any IP address. That's why this field is empty. Source address is empty. And destination address is broadcast address.
Broadcast address.
Okay. And your DHCP works, you should also remember, your DHCP works on destination port 67,
67.
UDP port 67. Okay. Another thing what we can see is what kind of packet it is. It's a DHCP discover message. Right? That's where you are getting your discover message. Now, any other DHCP message we are getting? No, we are not getting, because on R2, on your R2 machine, R2, on E0 by 0, this helper address command, this is your command to configure DHCP relay. Okay, let me remove this one. However, as of now, this is not doing anything.
Why we need to remove?
No, I'm just clearing it so as to show you that later on we will configure. Because it was pre-configured lab, that's why I had to remove this. Okay, this is the command when we need to configure a DHCP relay.
Okay.
Hello, good morning, sir.
Now, yes.
Sir, actually, I have get the link now. Actually, what?
Sorry.
I get the class link now. So, what is previously done?
Yeah, sorry, Sanjoy, you need to go through the recording.
Okay.
Okay, I cannot repeat. But
So,
yeah,
how many class previously?
yeah, all these questions, Sanjoy, has already been answered. This is our third class. So I request each one of you to please join on time. And if you miss anything, please try to go through the recording. Still, there would be any questions, I'm happy to answer them.
Okay. Okay.
Actually, we were told that this is the first class, and that's the reason we joined in today.
Who told this is the first class?
Yeah, the counselor
Yes, sir.
from networking, they told us this is the first class.
Yes,
We
sir.
got the invite like 2 days back for this class. You're not aware this is the third one.
Yeah, this
Yes,
is
sir.
third one. This is, yeah.
For me also, sir.
This
I
is
am now
third
getting
one
the
in
link.
the. No, got it. So in the first class, we just went through about the demonstration. That was a demo class. Okay, I mean what will be covered, what in the syllabus, and how we usually teach, that was covered. In our second class, I just went through some of the basics of IP routing. Okay, so maybe the counselor who is telling you, I mean, he or she is just telling you that almost it's a beginning. So if you join it, you will be definitely able to cover it.
And Atul sir also yesterday saying the same thing, sir.
Okay, then I'm not sure, but yeah, you'll get the recording. You'll get the recording. It will be there in your account.
Demo classes you have planned on 15 July, right? Last week.
Date exactly.
Last week, 15 July.
Yeah, 14th or 15th. Yeah, 15th, I guess. Yeah, you are right. 15th July.
Your counselor is after that. Your counselor is so we have an Enarsi, CCNP Enarsi. So we are start from 22 July, so that we are late because of I got yesterday the mail from your team side, so that we have missed 2 classes.
Okay. Nitin, may I request you to park all these questions for this end of this class?
Okay,
let's
sir,
go through it.
Thank you.
Okay, otherwise it will be wasting everybody else's time.
Yeah, go ahead, please. Thank you.
Okay, sure. Thank you so much. So what I was telling you that here on this 2 host interfaces, we have configured them as our DHCP client. Okay, by using the command at your interface level, interface E0/0, you have configured them as IP address DHCP. This is the only command that you need to configure in order to make that as a DHCP client on any of the Cisco device. Okay, next is how to configure a device or a router as a DHCP server. Okay, DHCP server, there can be 2 things. One is it's a locally available. Locally available means on the same broadcast domain. Okay, if this R2 would have been my local DHCP server, then here this will be called as my local DHCP server. It is because it is connected to same broadcast domain. Otherwise, your DHCP server can be a remote one. Okay, remote means it is not available on my local broadcast domain, but it is somewhere apart. It is some hops away. So in both the cases, the configuration of your DHCP server, what you need to define is you basically need to define your DHCP pool. How to define? IP space IP DHCP pool, and then you need to define the address. Okay, for example, here what I want is these 2 hosts, host 1 and host 2, should acquire an IP address from this 12.0 range. So this subnet I can define as a pool 12.0/24. Okay, now out of this pool, this .2 address I have already configured over here. So I do not want my DHCP server to assign any of the host this IP address .2, right? So this is basically .2 has been statically configured on this router, or it may happen that there are several servers in this VLAN. Let's say this is my another web server or any other server who does have an IP address, let's say .100, which is statically configured. So what I can do is I can configure this as IP address, IP DHCP excluded address. So all those address which I do not want my DHCP server to be assigned or to be leased to the against the DHCP messages, I can exclude them using this command IP DHCP exclude address, and I can specify either a single address or a range, or I can specify a range also. 10 to 12.100, that's how I can specify. Okay, I'll quickly show you this thing also. And okay, where I was. So another last thing, this configuration of your DHCP pool and your exclude address, this will be same in case your DHCP server is local or your DHCP server is remote. It will remain same. Okay. Apart from this, in case your DHCP server is remote, there is one extra thing you need to configure: your first hop router let's say, for example, this is R2 is acting as your first hop router. You need to configure it as a DHCP relay. Okay, how you can configure as a DHCP relay is on this interface itself. On this interface, R2 interface E0 by 0, you will configure. Basically, you want to tell that what is the IP address of my what is the IP address of my DHCP server, IP helper address, and the DHCP server IP address. Let's say 34.3. That's what I will specify. Right. Let us quickly configure them in our devices. Coming back to here on R2, let's say I configure IP helper address 168.34.4. Right. Coming back to our DHCP server. Here we need to configure IP DHCP pool. Okay. Pool and then the name of the pool. Let's say I give DHCP underscore pool. Okay. Then I will specify network. Okay, network number and the mask. 192.168.12.0. Okay, this is the network number. Either you can give slash or you can specify network prefix length or the mask. Okay, let us configure like this. Apart from this, I can configure a default router also. I mean default gateway on these two hosts. Okay, first let me do not configure any default address. Another thing, I will configure IP DHCP excluded address 192.168.12.2. This is I have
The lease expiry.
Lease expiry. There are some default things. Okay, by default, I think it is 24 hours. We'll see that. We'll see that. Okay, I mean that's not a mandatory thing. That's an optional thing. If you
So why
see,
exclude 12.2 IP
sorry?
address? You given now IP address exclude 12.2.
Yeah, because this 12.2 is statically configured on this interface E0 by 0 of R2. I do not want to send it as a leased message.
Okay, sir. Got it.
So now coming back to this one, can you see against this discover message? You got an offer now, DHCP offer, right? This offer message, source address 12.2. What happened actually? I'll remove this one. Come back over here. This host sends a discover message, right? This R2 receives that discover message. R2 relayed that message to 34.4, same as a discover message, right? DHCP server responded with a which message? Offer message, right? This offer message, R2, since it is acting as a relay, it will send as a broadcast message, that offer message. Coming back, can you see this source address 12.2 for this offer message, DHCP offer? 12.2 is who? R2 is acting as 12.2. It is being sent to your broadcast address, offer message, correct? Relay agent IP address 12.2. Or if I show you what are the contents of this offer message. In offer message, your client IP address, see, he has offered 12.1 to me. For host 1, I have been offered 12.1. Along with this, you are asking lease time. Can you see this? 86400 seconds, 1 day. Okay, so this lease time you are getting. If you want to reduce this, yes, you can configure on your DHCP server. All right. So this is going towards your host, or it is being broadcasted. Now your host is sending a request, DHCP request, discover, offer, and then request. This request message is again, if you see, source 000, destination 255.255.255. Okay, port 67. Right, within request. Okay, I'm requesting for this IP address. Okay, I'm okay. Please request, please send this IP address to me. Last is your DHCP acknowledgement. So in your acknowledgement, if you see source address 12.2, since it is acting as relay, then your client address 12.1. Okay. This has been allocated with the lease time of 1 day. If coming back to our DHCP server, show IP DHCP bindings. Can you see this 12.1 has been allocated? Lease expiration, this one. If I show the clock, can you see 22nd July, almost 5:20. I mean, maybe it was 5 minutes ago when this was leased. So after 1 day, it will get expired. Your lease expiration is 1 day by default.
Sir, I have a question.
Yes, please.
If that release time has expired, that IP previously released, that is not currently working. So previously it was released. Can I show that which MAC address that IP address is being released?
No, sorry. Can you repeat
Like,
your question? You're saying that after releasing this IP address, can I
this
have
IP address 12.1?
log?
Hello.
Yes, yes.
12.1 is released now. Okay. So I reboot or release or renew, that IP address will be goes down, and second another IP address will be assigned there. But I have to check that 12.1 is assigned to which MAC ID. Can I check that? But lease was expired already.
No, if it is already removed, then it will not show you over here.
Okay.
Then it will not be visible. If lease is expired.
Okay. Thank you.
Okay. Still people are joining. Any question, guys, on these 4 messages? Discover, offer, request, acknowledgement. You should remember them. I mean, you can remember them as a Dora process in your DHCP. All messages are being exchanged as a broadcast. Okay. What is the purpose of the relay agent? Server, how we are configuring, client, how we are configuring, you should know. For
And
your
one obvious question is, there are multiple DHCP servers sending an offer. I think the client will pick up the first one, or is there any other preference?
No. Client will configure the first one, or I mean, there would be there are some things. That's how you can configure their preference, and some filtering can also be applied to
That's
avoid
exactly what I
your
was
ROG server.
about to ask. Is that something done on the DHCP server? Like, to give a preference if there are 3 servers responding, the client, even though let's say the second server offer came late, probably the client should pick that first because that has more weightage or something.
Yeah, that security is generally configured on our layer 2 devices, on our switches. Because let's say, usually how it happens is, in our enterprise infrastructure, there would be a switch in between. Okay, on this switch, I'll configure that as a DHCP snooping, it's known as. Okay, so I'll snoop all those DHCP messages which are being exchanged. All the you can think that we have 4 types of messages, right? Discover,
Dora, yes.
offer, Okay, request and acknowledgement. Out of these two packets will be going out from this interface.
Correct.
Correct. And these two packets will be coming in from this interface. Now, as an administrator or as a network engineer of your infrastructure, you know that my DHCP server is connected onto this interface and none other interface does have any DHCP server, and it should not have. I mean, let's say within your company itself, there is a person who does have access to these devices. Okay, and let's say he configured his laptop or he connected his laptop onto this interface, and on his laptop he configured something as a DHCP server.
Okay.
And you want to prohibit that. You want to stop that, right? Because this is the device that is in your control. You are administrator of this device. So how you can do is on a high level, I'll tell you, this is known as DHCP snooping. You are snooping all these messages, okay, and you configure that only this interface can receive offer and acknowledgement messages. None other interface should receive offer and acknowledgement messages. So then when this device is sending you an offer message, you will drop that message over here itself.
Okay.
Okay. I'm telling you the concept. The configuration wise, there will be different
It's at an interface level, right? Whatever configuration.
It is, yeah, it is configured. Normally, it is configured at a global level. And then on this particular interface, you will define this as a server interface. That means you can receive this offer and acknowledgement messages rather than configuring all the rest of the interfaces, because you know that this is my legitimate interface. You will configure or you will allow the messages only on this interface.
Got you. So you enable DHCP snooping globally at a switch level, and then you configure the server at the interface.
Correct. That's
This is helpful. Thank you.
Okay. Okay. Coming.
Hello, Gaurav.
Yes, please.
If the both routers we want in different subnet, different network, and we have different DHCP server, so how we can do that?
No, can you repeat your question? What was your question?
My host 1 and host 2 we want in different network.
You want them in different network, right?
We have multiple DHCP server. So
you have multiple DHCP client or multiple DHCP server?
Multiple DHCP server.
Multiple DHCP server. Okay, let us assume that here also you have a DHCP server.
Yes.
Correct. And let's say this is your 35.0 subnet.
Yes.
Okay. Now, and you want that this host 2 should get something from this server.
Yes.
And host 1 should get from this server.
Yes.
Is that so?
Yeah.
And are they part of same network 12.0 only, or they are from different VLANs?
It may be something same. I want that host 1 will receive the address from
that is clear. This is, let's say, DHCP server 2, this is DHCP server 1. Now the question is, on this host 1 you want IP address from DHCP 1, okay, and host 2 you want from DHCP 2.
Yes.
Now my question is, these host 1 and host 2, are they belong to same VLAN or different VLAN?
Different.
Okay, let us assume this belongs to VLAN 12 and this belongs to 112, right? And between these two, I mean, 12.0 is your VLAN 12, and 192.168.112.0 is your VLAN on this one, correct? So definitely on this interface, you will have two different IP address. One is, let's say, E0/0.12, and another one is E0/0.112, correct?
Okay.
Okay. Now on your interface E0/0.12, you configure IP helper address 192.168.34.4. Similarly, on your E0/0.112, you will configure IP helper address 192.168.35.5. So all the DHCP requests that you are getting from host 2, they will be relayed to 35.5, which is your DHCP server 2. Does it make sense?
Yes.
Yeah.
Okay,
So
that's
if
how
we
you
code
can do.
both,
Sorry?
Gaurav, I have one question.
Yes, please.
If we are giving helper address to 35.5 to 112, if DHCP server 2 is shut down, so it will be taking IP address from DHCP server 1, or it will not allocated?
No. Have you configured it? No. Under
So
this,
if you want
you are not
to
configured it.
if you want to configure like if you want to
Multiple.
allocate IP address, you want to configure multiple helper addresses.
Okay, it's a good question. Let us see. There should be something on R2. Zero. Does it allow me to configure another IP helper address? Yes, it allowed me. We can put them in a redundancy group. Yes, it is possible.
Okay.
You can configure them in a single redundancy group. Okay. Otherwise, if we are not putting them in a redundancy group, I believe they both will get your discover messages, and then your client has to decide among one of them.
Okay. Got it.
Anybody have any other question?
Sorry, just for completeness, if both of them are in the same VLAN, then you can't define the same thing, right? Like I can, like the host 1 should get it from 34.0 and host 2 should get it from 35.0.
Yeah, that correct.
There's no way, right? Or
Yeah,
is there
and
anything?
I don't think there is a way, and I don't think this is a use case also. It's not a
Correct.
valid
Because
use case
it's
basically.
for one VLAN, I have one DHCP. You can't have.
Correct.
Correct.
It makes sense also. Yeah, it
Same
makes sense.
broadcast domain. Perfect.
Yeah.
Yeah.
And
Thank
also,
you.
I mean, from the use case perspective, also nobody wants to have per host DHCP server. No, per VLAN DHCP server, it makes sense. I mean, if we see the practical use case also, it doesn't make any sense that, okay, for let's say 50 hosts, I want to achieve or get IP address from one DHCP server. For another 50 hosts, I want to receive from another DHCP server. That makes sense only if they belong to different VLAN. But within the same VLAN, I want to use a DHCP server. I don't think it's a valid use case also.
Yes, I think you have a point. Thank you.
Right. Good questions. Okay, this we have covered IPS DHCP. That's
sir,
how we
in same
configure our.
VLAN, in same VLAN, I can put that true DHCP IP helper address.
Yes, you can put. That's how we saw now. I mean, we can configure the multiple helper address on the same interface, same tier 3 interface. Okay, another thing I would like to show you. See, as of now, our DHCP server, what we have configured is if you see, this is the only configuration that we put on our DHCP server, right? And our host 1, he has got an IP address, show IP interface brief. So this 12.1, it has got. If I show IP interface E0/0, if you see, this is the address we have got, correct? Address got by DHCP. Do I have any default gateway? If I route, if I see, I do not have any default gateway, right?
Yeah.
That can also be given from your DHCP server. If I configure this within this, guys, please go on mute. 50. Default router 192. 168. That also you can configure. Okay, let us check on host 2.
Sir, can I put the DNS also?
Brief. Yes, you can put DNS also. Yes. I think name server was the command. Server. Yes, you can put. Right. Coming back to our host 2. Let me remove this IP address. Okay. It got an IP address now. 12.3. Okay. And if I check show IP route, it got a default gateway also. See, default route I got the next hop 12.2. Can you see this AD value 254?
Yeah.
Okay. It's, I mean, least preferred. If I would have any other default route within my routing table, then that would be more preferred. Since we are configuring or we are using our routers as a host device, that's why we are able to see this routing table. Within Windows also, I think we can see that routing table, but it will get that IP address only. If you check show IP interface E0 by 0, IP address assigned by DHCP, then you see the name server, or how can I see? Okay. And once again, see now this has been assigned this 12.4. Okay, and what else? Allocated IP address 12.4. I want to check where is the DNS server. See this DNS server name server option. This is also what you are getting. This is nothing but the same thing what you were seeing in that Wireshark output. That's how you can see via debug DHCP details on your client machine. Okay, it is showing you what is your lease time, what is your renewal time. This renewal time is exactly half of your lease time. Okay, I mean exactly in your within next 12 hours, it will send another discovery message to your server so as to get this renewed. Okay, it's, I mean by default it is half of your lease time, right? And what else I can tell you over here? Okay, few things. So in your DHCP server, let's say I'm configuring the pool as 192.168.12.0/24. So as per best practices, how we generally do in our practical scenarios. So first 10 IP addresses from 12.1 to 12.10. Okay, we usually exclude them from the pool. Okay. Also, in some of the plans or some of the design things, the last IP address of the subnet, let's say 254. Sometimes, I mean, this also being followed, that last IP address is assigned to your device, to your router. Okay, last usable IP address. So in that scenario, I mean, the last few IP addresses, let's say 12.244, I mean, last 10 addresses you can exclude. But generally, you should keep a buffer that so many IP addresses I'll exclude. If let's say in your working network, you have to connect a server over here. Okay, you have to provision a new server over here. So generally for your servers, you do not want to get the IP address via DHCP. You manually configure them because it's a one-time exercise. Okay, so for these servers, you should keep several IP addresses which are excluded from your pool, so that later on at any stage you can assign them from this pool. Okay. On your client machine, you can use this debug to troubleshoot, debug DHCP packets or DHCP detail. Yeah. On our servers, how we can check this DHCP server. How to verify show IP DHCP pool. This will show you how many total addresses do we have in our pool, how many have been leased till now. Okay, what is the current index? Okay, 12.4 has already been assigned, so next is 12.5. If next I'll get any request, I'll assign this one. This is my range, and out of this range, only 2 addresses has been assigned. Right? Show IP DHCP server statistics. Yeah. Here also you can see how many discover requests I have got till now, how many DHCP request messages I have sent, how many release requests I have got. So if I shut this host, or when I was doing the shut interface command, so it was basically sending a release message also. If I show you on this host, when I shut that interface, see this administratively down. Okay, when I made this down, so it must have sent a release message. See, this DHCP release has been sent. See, DHCP release called for interface E0/0. Okay, earlier it was assigned this 12.3. So I'm sending a message towards the DHCP server that you can release this message. I'm shutting down my interface. Okay, that is known as your DHCP release message. Okay. What else? DHCP server statistics. You can see IP sockets if it shows. No, here it does not show. 50 service DHCP. So normally this service DHCP should be on. Enable DHCP server or no relay. If I shut this service, then your DHCP server will not be. I mean, this device will not be running your DHCP service. I can shut this like this. In some of the scenarios, if your server is misbehaving or not working properly, you can check this service show run all. If you check include DHCP, you can check, should be somewhere visible over here. Service DHCP. It's not visible in the running command, but That's how it is configured. Service, I think it's a hidden command. That's how it is configured. Service DHCP. By default, it is on. Okay, you can undo that also. No service DHCP you can configure. Okay. Any questions in this one? DHCP. This was known as also known as DHCP IP version 4, because here you are configuring for your IPv4 package, not for IPv6. Okay, coming back.
Hello, Gaurav.
Yes, please.
So if we want the MAC bind IP address assigned to host one, it is possible.
Yes, it is possible.
So how we can?
Yes, it is possible.
It
is configured on your DHCP server. Correct. Correct. It is possible. It is possible. You need to configure it on your DHCP server. If I show you, show IP DHCP binding. So in this binding, this is your client ID basically. Hardware address and username. Based upon these three things, this IP is being assigned. Okay. There is a field, I mean, you can define that also. If I go to host 2 and check show interface 0 by 0, see this MAC address is AA, BB, and then this last is 4000. If I come back over here, it should be somewhere visible over here. Or I think it is in some format it is encrypted, but that is definitely doable. It's a very common use case that I want to lease the same IP address for this particular machine. That is doable. That can be done based upon the hardware address. I mean, hardware it's your MAC address, or the client ID that can be configured on your client machine. That is possible. Okay. Okay. On your server, you can configure like this: debug IP DHCP server events. That's how you can see. If I show you, sorry, not in config, debug. All your debug statements are configured in your normal mode. I mean, you not to go into config mode. Debug IP DHCP server events. So it will show you the logs against on the DHCP events. I go back over here. I shut this interface. One down. I know shut. This is it's getting a discover message. Okay, a remote ID you are getting. This remote ID is kind of that client ID. Okay, circuit ID you are getting. Address 12.1 is being allocated. Lease time is this one. So you can, I mean, using this debug statements, debug IP DHCP server events, you can try to troubleshoot whether I'm getting a discover message here till here or not. Okay. Server packets that you can configure. Okay. Any questions on DHCPv4? Else we can switch to IPv6 addressing.
The MAC binding thing, can you show that?
Sorry?
MAC binding.
Yeah, MAC binding, it can be configured. I think it's not given over here, but I can write it as a task. I'll come back to you for this one. MAC binding.
Okay.
With specific IP. That's what you want, right?
Yes, sir.
On DHCP server. I'll cover that, no worries.
Okay.
Okay. So next is our IPv6 addressing. How many of you are aware about IPv6 addressing, or have got chance to work onto it, or studied it in your course?
Sir,
Anybody?
IPv6. Yes, sir.
Sir, I worked in Geo.
Yes.
Then Geo use IPv6 address
Okay.
/128.
Okay. Fine. Fine. Okay. So because it's not when full-fledged IPv6 addressing, we are not going to study over here. I'll just cover some of the basics around IPv6 addresses. Let me open some of the slides. Okay. IPv4 address, you all know that this is our 32-bit address, right? 32-bit address. So how many total addresses we can have? 2 raised by 32. So that are getting depleted. That's why IPv6 was originated, which uses your 128-bit addresses, much larger, very much larger than your usual IPv4 addresses. So 2 raised per 122 coming out to be this value, which is, I mean, very difficult to even pronounce. Okay, so we can have a large number of IP addresses in your IPv6 using your IPv6 addresses. So what you should remember is, at least you should be aware that this is your 128-bit address. Okay, next is addressing format. Yeah, this is important. So you should be already knowing that your IPv4 address 32-bit, they are represented in a dotted decimal notation. 4 octets, octet A, B, C, and D. Each octet is of 1 byte. Okay, which for each octet values can range from 0 to 255. Since this is your 8 bits. Okay, in binary. However, in case of your IPv6, this is represented in the hexadecimal notation. Okay, why hexadecimal notation? Because if we try to represent this in a binary format or in a decimal format, it will become a very big number. That's where we are representing in a hexadecimal notation. I will assume that all of you are very well aware about what is hexadecimal and how to convert between decimal to binary, decimal to hexadecimal, and the other way around. Okay, in our IPv6 hexadecimal notation, how it is represented is, it is represented in the form of hexstats. Earlier, here we are calling them as octet. Here it is known as hexstat. Okay, so each hexstat is of 2 bytes. That means 16 bits. And how many such do we have? 8. So 16 into 8, that becomes your 128 bits address. Okay, you can remember like this. 128 bit is the total length of your IPv6 address, and 8 are the hexstats. So each will be represented with a 16-bit number. So this 16 represents your binary bits. Okay, sometimes it becomes confusing that we are somewhere we are talking about hexadecimal, then we are calling them as binary bits. Okay, so this 128 is representing our bits in the binary, the number of bits. However, it is represented in the form of hexadecimal notation. So hexadecimal, if value goes from 0 to 9, and then A stands for 10, B stands for 11, C, D, E, and the last is your F. Okay, 0 to 15. Right? 0 to F in the hexadecimal notation. Okay, my prefix length also. So in your prefix length, our IPv4, how we represent our subnet mask, either as a dotted decimal notation like this, or as a CIDR notation like slash something, /24, /28, /30, 32, whatever, right? So this represents number of consecutive ones starting from left. Correct? But since in IPv6 address, we have a 128-bit length. So if we try to represent in a dotted decimal or dotted hexstat notation, it will be difficult. So that's why in your IPv6 address, we only have this CIDR notation to represent your subnet mask. All right. We already know that what is subnet mask, what is its significance. We covered that in our first class. Anybody who was not present in our first class, please go through the recording. Okay. So for subnet mask, we are using CIDR notation in our IPv6 address. So each hexstat, for example, over here, each hexstat is of 16 bits. And when we are saying the 64 as a subnet mask, so that means our first 4 hexstats, they should remain same in order to consider all the IPv6 address part of same broadcast domain or same LAN segment. Right? C6 length example. So see, when we say /32, so that means our first 2 octets. So, this one, 16 plus 16, they should be same. Okay, when we say /32. When we say /48, that becomes your 16 plus 16, then another 16 extra. Till here, it becomes same. /52, 4 more. 4 means 1 hexadecimal number. Correct? /64, when 16, 16, 16, 16, 4 hexstacks. This is your /64. Correct? Another thing I would like to tell you over here, this is important, guys. So IPv6 addressing rules. I mean, how to represent your IPv6 address. So first rule, it says omit leading zeros. So leading zeros means from your right hand side. Okay, if there is a 0 over here, we can omit that. Sorry, not from the right hand side. My bad. From your left hand side. Let's say this is your number. These left 3 bits, if they are 0, we need not to represent them. We can represent them as a single 0. For example, in this IP address, IPv6 address, if you see FF02 colon and then 3 zeros and then another 0, we can represent this as a single 0 also. I can omit my leading 3 zeros. If there were 2 zeros, then also I can omit them. Okay. For example, if it was like this FF02 colon 00 and let's say 81. Okay, then this could have been represented as FF02 colon 81. This is one and the same thing, right? So rule number 1 says that we can omit our leading zeros to shorten the IPv6 address length. Second thing is, if there are consecutive zeros, okay, like one hexstat, this is 0, another hexstat, this is also 0. For example, in this second example, if you see this is 0, all zeros, they both can be omitted together rather than putting them as 0 colon 0. What we can put is, we can either write them as like this, or we can remove the consecutive zeros and put these 2 colons together. Okay. Is it clear, guys? Any questions? So this consecutive zeros, they can be replaced with either 0 colon 0, or if I want to further shorten them, I can represent them like this. Okay, but see, in this example, this 3 hexstats, they are also all zeros, and this one is also all zeros. If I make this like this. So either we can represent these as 2 colons, or I can represent like this. In single IPv6 address, at 2 places, I cannot have this 2 colons multiple times. There can be only single double colon that is accepted in your IPv6 address. Is that clear? Any question?
Sir,
in
rule
these
number
2
2.
rules?
Sir, rule number 2. You highlighted the after FF002, and after that 000.00.00. So you are mention the double colon, right? 400.
Either you can represent this. This is one IPv6
Last
address,
one,
correct?
last one you are highlighted in the yellow part. So why we are not using a here double colon?
No,
After-
we are using double colon. We
No,
use double
first
colon.
one, first one.
This one?
Here, yes.
No, that's what I'm saying. This double colon can come only once in your IPv6 address. In your complete IPv6 address, I can only have this one time.
Okay, one time we are using double colon.
One time. It is not accepted more than one time.
Okay, okay.
Only single double colon can be accepted. Either I can convert this as a double colon, or I can convert this as a double colon. So these both are valid. This one is valid. This one is valid. But if I try to write it as like this, ff02 colon 3, then colon 1. This is
Yes,
not
sir,
acceptable.
understood.
Right? This
Yeah.
is not acceptable. So these two methods, these two rules are to shorten our IPv6 address. First thing is you can remove these leading zeros, okay, against a single zero or the number. You can remove
Yeah, rule
this
number
leading
is
zero.
all clear, sir.
Okay.
Yeah,
Rule number 2 is
Mhm.
consecutive zero hex text can be replaced with a double colon,
Yeah, sure.
but only once. Only
Yes.
once.
So double colon we are using only for one time, right?
Only one time
Yeah,
in
okay.
your IP
Understood.
address.
Yeah, thank you so much, sir.
Correct. IPv6 address ranges. Okay, this is also you should be aware that as like in our IPv4 address, you must be knowing that we have different classes: class A, class B, class C, class D. Right? This is ranging from your 0 to 127, I believe, then 128 till 191, 192 till 223, and 224 till something like 248 or so, right? That's how we are dividing our IP address range. This is based on your first octet, right? Similarly, in your IPv6 address, we have our higher order bits, which are defined. Defined means they are for specific purpose. For example, this FE80, this is reserved for your link local unicast addresses. You cannot use any other IPv6 address which is starting from any other range. Okay, this is designated, or this is reserved for your link local addresses. Similarly, multicast addresses, they'll be starting with FF00. Unique local address, link local address, these are your FC00. Global unicast address, they will start from your 2000 series. Okay, /3. /3 means what? 2000. How many bits does it have? This one. If you see, this is one hextet, right? One hextet is of 16 bits. So this number is of 4 bits. Okay. So 2 means 1 0. It will be represented like this. And when we are saying /3, 3 means first 3 will remain same. So what else we can have? We can have this also. So all your IPv6 address starting from 2000 and ranging from this one. Sorry, 3FFF. Sorry. Okay, they are part of your global unicast address. Any question?
Can't understand, sir.
You can't understand. Okay. I was expecting this. No worries. So if you see this one.
Can you please, yeah, below one, F0 CC, so that we can understand.
No, I am saying this one, global unicast 2000/3.
Yeah, okay.
Okay.
Yeah.
2000 and then colon. we do not have any dotted decimal notation. It is, I mean, all your hex text are being separated by a colon over here in your IPv6 address. Right? When we say /3 means this is my mask, right? So mask means how many bits starting from left should remain same. If I represent this 2, this complete 2000. How many bits do I have?
How many
16
bits?
bits.
4 bits.
In binary, how many bits do I have? This is your
16.
hexadecimal notation. This is representing your 16 bits.
16.
Correct. So each bit, it can be your 4 bits.
4 bit, right?
Can you tell me why 4 bits?
Division, na? 4.
No, yeah, you have divided, very nice. But why it is 4 bits? Why? Because this is your hexadecimal notation.
Hexadecimal
In your
value.
hexadecimal,
2 power 4 is
you can
16.
have 0 to 15 numbers. Okay, right? How can I represent 15? I can represent, if I convert it into binary, I need 4 bits.
1
1,
1
1, 1, 1. Right? I need 4 bits to represent this number. That's why this is your 4 bit. So when we are saying 2000:/3, that means to represent this 2 means 0, 0, 1, 0 in binary. Right?
Yeah.
To represent this number 2. And I need the first 3 bits starting from left hand side. First 3 bits should remain same. So what else I can have? I can have this thing. I have kept this 3 bits exactly same. Right? So what this number becomes? 3. So starting from 2000, next number will be 2001. Next number will be 2002.
Yes.
Correct? And so on. It will go up to 2FFF in your hexadecimal. After this one, what will be your next number? Next is 3000.
3000.
It will go to 3FFF. Correct?
Yeah.
After 3FF, what will come?
4.
Does 4 belongs to this number, global unicast? No.
No.
Because
No.
I want to keep these 3 bits as same. So that's what I was telling you, that this range of a global unicast will start from 2000 and it will go till your 3FF. That's what I was telling you. Okay, this one.
Global is in the public ID.
Yes, it's global unicast. Okay, it's globally routable. As like in our IPv4 also, we have several private IP address range and some public IP address range. Correct? So your 10.series/8, your 172.16 till your 172.31/16, and your last one, can anybody tell me?
192.168.0.2/24. Yeah.
Not /24/16.
16.
Right? This is our private range. So what private means? I cannot route them towards internet. Similarly, I mean, apart from this, whatever else is there, that becomes our public. So that means that can be routed on the internet. Similarly, over here, this global unicast is publicly routable, and your this one FE80 and your FC00, these are your private range. These are locally significant, unique local and link local. Okay, they can be duplicate, but this should be unique. right? So quickly moving.
So even that, sorry, one question. So 2000:3, how many addresses we'll have? We'll have a lot of addresses, right?
Lot of
Because
addresses.
that's just the first octet /3, right? And then the
This is
other
first
octets.
octet. Yeah.
And then
You're
I
right.
have 4 more pairs of octets that I can.
Correct. So many IP addresses. Yeah, a lot of addresses. You can waste as many as you want, but in IPv4 we have to think. Okay, global unicast manually configured. Okay, link local also I'll tell you. Then we'll move back. So link local, as I said, that starts from your FE80. Okay, it always starts with your FE80 range. /10. /10 means your first 8 bits and 2 other bits of here. First 8 bits and 2 other bits, they should be same. Okay, this is equivalent to your this address in IPv4, 169.254. Okay, link local means that, for example, this is your router. These are 2 routers, they are connected together. And let's say here also you have another link. Then it may happen that this link local is only significant over this link. Let's say I'll configure FE80::, and then 1 over here and then 2 over here. Okay, it may happen that this interface I can also configure FE80:1, and here I configure FE800:3. It can happen because it is link local. It is locally significant over this link. I'm not advertising it anywhere else. Are you getting my point? This IP address, link local IP address, it is significant between these 2 routers only, and that too only on this link. I can have the same link local address on any other link also, since I'm not advertising it anywhere. It can be configured manually or it can be configured dynamically. As soon as you enable IPv6 on your interface, it will automatically assign a link local address onto that interface. Okay, there can only be 1 link local address per interface. 2 interfaces on same device can have same link local address.
Sir, if you want to advertise that link local address to another router, is it possible?
No, we don't advertise.
Okay.
No, it's not routable basically.
Okay.
Can you advertise? If you see the analogy, your MAC address, it does have another MAC address. These MAC address, do we advertise them towards any other router?
No.
You don't advertise. They are locally significant in this domain. Correct? That's where it is also your link local. This is locally significant.
So in link local, MAC address also included there?
No. MAC address is not included. I quickly jump onto this one. Let me show something. On your R2 router, to run interface is 0/1. Okay, if I just enable IPv6 over here, IPv6 enable, and command to see IPv6 things are up to IPv6 interface is 0/1. Can you see this link local address?
Sir, your voice is too much slow. So can you please speak loudly?
Okay. Am I audible now?
Yes, sir. Please go ahead.
Okay. So I was saying that on this interface, we just enable IPv6. Okay. And it automatically configured a link local address. It is starting with a FE80. Correct? It got automatically configured. IPv6 is enabled. We have not configured it manually. See, I've just given this.
Yes.
Sorry.
Like MAC address?
You cannot say like MAC address. It's a MAC address is burnt in address. If you see BIA, this is your burnt in address. This remains same. You cannot change this one. Okay, but this link local address can also be manually configured. Although this last part, can you see there is some similarity between here and here?
Sir, is this same as IPv4 APIFA IP address? The 169 series.
Yeah, it is similar to that one. Yeah, similar to that one. But what I wanted to tell you is, first thing you should remember, it is locally significant. Second thing, it always starts with FE80. Okay. Third thing, automatically when it is being configured, it is being generated from your MAC address. Okay. How it is being generated from your MAC address? I tell you. Let me capture this MAC address. Okay. Now, what it does is it breaks that into two parts. From here, if I just break it. Okay. And in between it, I will insert FF:FE. This I'll insert. I'll change this dot with the colons. Okay, sorry, this one. So this is what I inserted. Okay. Post that, another thing is the 7th bit from the left. 7th bit from the left, I need to invert. If it is 0, I'll make it as 1. If it is 1, I'll make it as 0. So A means, how can I represent that in the binary? 1000. So this first octet, if you represent that in binary, this will become our binary for this one, AA, So 7th bit, 4, 5, 6, and 7. Let me copy and then I'll invert this 7th bit. This is my 7th bit. I'll make this as 1. So 0, 1, 2, 3, 4, 5, 6, 7. Okay.
A is represented as in binary 1010.
1010. Yeah, I think I made that mistake. 1010, 1011, 1011. Okay, thank you. Now 7th bit, 4, 5, 6, 7. This is your 7th bit. If I invert this one, 7th bit I have inverted. Now convert this again into hexadecimal. What it will become is your first 4 bits A, then your next 4 bits. What is this number? 8.
8.
Okay. Next 4 bits
B.
Sorry. B and then again B.
B.
A8BB. So this will be changed with A8BB. Okay. And then you will append this with FE80 : : that is your derived link local address. All right. Your first thing is break your MAC address or split your MAC address in 2 equal parts. Correct. Second thing is insert FFFE. Okay. replace dot with colon. Correct. Third thing is invert 7th bit from left side. Fourth thing is append FE80 in the beginning. That's how you are deriving your this link local address. Any question, guys?
I think it should be prepend actually because it's just putting it at first.
This one?
Yeah, it should be prepend FE8.
Yeah, makes sense. More. Yeah, correct. You can prepend this. Right? So that's how it is being derived. But I mean, the things that you should remember is for your link local address, locally significant. Second thing, FE80 always in the beginning. Okay. If it is being dynamically allocated, then it is being your MAC address is being used to derive the link local address, and these are the steps. That's how it is being derived. Right. Coming back to link local. That's how it is derived. Okay, EUI64, another thing I'll tell you. So this there is another method. If I go back over here, 0 by 1, interface E0 by 1. I can configure IPv6 address, let's say 2001::2/64. I can configure like this. If you check do show IPv6 interface E0 by 1, you can see this is global unicast address. That's what you have configured. Correct? This is manually you have configured. But you can make this also being derived from your MAC address, IPv6 address. Okay, I'll configure 2001::/64. Okay, EUI64. Now, if you check show IPv6 interface E0 by 1, can you see this one? If I copy this, paste it over here. This is exactly similar. The only difference is your instead of FE80, this is having what you configured 2001. Rest of the part, that's how, I mean, same logic it is using to derive from your MAC address.
Okay. Why it is needed basically?
Because let's say you do not want to configure them manually.
Okay.
You want them to be derived from the MAC address itself.
Okay.
Okay. So this is the same thing that I have already told you, that we take the MAC address, split it into two pieces, insert FFFE in between, replace the dots with the colon. Okay, and invert the 7th bit. Same logic it is using. Okay. Coming back to our book. So
whatever is assigned there are private addresses, that EUI64. Sorry, I don't remember the table that.
No, yeah, private and public is being represented with the first, with the first hex tag. This is representing whether it is a private or public or is a unique local or link local. This is representing that.
Okay, and what is EUI64 IP addresses?
EUI64, it is we are generating. Basically, you configured you configured this as a range that I want my IPv6 address to be generated from this range, but the exact IP address please derive from the corresponding MAC address. So the IPv6 address that you configured on the interface has been derived from this subnet using EUI method.
So it is global unicast?
Sorry?
It is global public IP?
Yeah, this is global unicast.
So this is some sort of like a DHCP server, but because it's MAC based, so
no,
it's going to be
locally
unique as well. No, I'm saying the concept is
unique.
like kind of
that. Yeah, concept is dynamically deriving.
And it's
without
the
any
unique also because it's based on MAC address.
Yeah,
So
yeah, correct. It will not duplicate.
very interesting concept. Yeah.
Because many of the times you do not need the interface IP addresses. You work. I mean, you just need to them as a transport address. You need that. Okay, my AGRP or my neighborship should come up.
Correct.
That
You don't have to manage it actually.
Yeah, right. Correct. I do not have to manage. I don't want to manage them. So between these devices, I just want to have the connectivity. Okay. Otherwise, my local LAN, which let's say here my PCs are connected, here my servers are connected in my data center. Okay. On this switch, I do not want to manage the link addresses between these devices. So I can derive via UI addressing. Okay. I am only concerned that this host should be able to communicate with this servers. That's it. Doesn't matter what IP address you are using over here.
Thank you.
Okay, coming back over here. One last thing I should cover. I'll do it later. So on our Windows machine or Mac operating system also, you have this IPv6 address automatically there. It's already there. Okay, both the things are there. IPv6 address as well as link IPv6 address, link local, IPv4 address, subnet mask, default gateway also you'll get. Okay, UI64 we have covered. Okay, ipconfig/all. This command is used in our Windows machines. That's how you can see. Okay, physical address is nothing but your MAC address. DHCP enabled, yes or no. Okay, auto configuration. That's how we configure UI64. Show IPv6 interface is the command used to verify. Okay. Okay. Now there comes the concept of there are three things. Okay. One is in dynamic allocation. One is your SLAC. SLAC stands for your stateless address auto configuration. Okay. This acronym I always used to forget this full form. I try to remember, but I don't know why I always forget this one. Stateless address auto configuration. Okay. Next is your stateful DHCPv6 and stateless DHCPv6. So stateful is similar to how we have in our DHCPv4, where we were configuring a DHCP pool on one of the DHCP server. You are sending some discover message, receiving the offer and request messages. Similar kind of messages will be there in your stateful. Okay, and there is a stateless message also. I'll cover them quickly. In your stateless address auto configuration, how it is done is that's how you configure IPv6 address auto config. If let us do it in our lab also. IPv6 address auto config. Okay. I think I should have this now slides also. Neighbor discovery protocol. Let's neighbor discovery underscore. I do edit configure. Show E0 by 1, huh? Show run E0 by 1. There we have configured this UI64. Let me basically remove this one, E0 by 1. Now IPv6 address 2001 colon 64 EY. Yeah, IPv6. On our R3. Okay. If I configure this thing,
The DHCP pool creation and remaining the same process for
sorry.
IPv6. DHCP pool configuration
Uh-huh.
remaining the same like IPv4.
I'll show you. I'll show you. There is a little bit of difference. I'll cover that part. Okay. First, I want to cover this stateless address auto configuration. I think we have a lab also.
Hello, sir.
Yes, please.
How to configuration DHCP in Linux machine?
You need to Google that out. It's not part of our Enarsi course. Okay. Somebody on the way. Devices. So first, I'll tell you how to configure. I mean, let us assume that this is our DHCPv6 device, and this is our R2, which will act as a client. R2 will act as a client. First, let me power this off. Okay, only these two machines we have powered on. I'll log into these two. R2, which is acting as a client. Okay, and this will act as my server. From there, I'll get the IPv6 address. So I'm going to 0 by 0. Let me see how I configure them. So
We are learning here stateful and stateless, right?
Stateful and stateless, yes, both.
Okay.
First, I'm covering stateless.
Yeah, okay.
Sure. So there is no configuration till now on these two devices, okay, with respect to your IPv6. For this one, if I on R2, okay, you will configure like this interface E 0 by 0, okay, IPv6 enable and IPv6 address. If I configure this auto config, so I want this IPv6 address to be automatically configured. Okay, how it will be configured, I'll show you. This is auto config, right? Right now it is in a shutdown status. So we'll capture the packets also. And on your DHC, I mean this machine. Okay, basically
Yes.
this device, your the client machine. Here I'm using stateless address auto configuration. Basically, I'll configure this as a auto config. Okay, so I mean that any other device which is connected on this link, he should provide me the IP address information. He should tell me. Okay, how he should tell you is, let us see quickly. On this machine, okay, connected machine, on the interface E0 by 1, or before that, I should configure this IPv6 unicast routing. So anything I need to do in my router for IPv6? I should basically enable this command, IPv6 unicast routing. For IPv4, you need not to enable because your device already have IP routing enabled. This is by default enabled. IPv6 unicast routing, you have to enable.
So can you run parallelly IPv4 and v6? Both?
Yes, you can run. You can run. That's known as dual stack. That is perfectly possible. In most of the practical scenario, yes, we have parallelly being running. Okay, but you need to make sure that your devices would have a additional consumption of memory and CPU resources that you need to plan. But yeah, they can run parallelly. Okay, on this, firstly, I have enabled this IPv6 unicast routing globally on this upper router. Next is on this E0 by 1, I'll configure one as IPv6. Let's say I configured one IP address 2001. I'll give something like this. :2/64. Let's say I put like this, right? And I made this as IPv6 DHCP server. If I want to give, I can give a name also. Under this device, let me configure IPv6 at DHCP pool. Okay, let me name it as a stateless name. You can give anything. Okay, within stateless, I'll not configure any network or I'll not configure any addresses. I'll just configure a DNS server. Okay, DNS server. Let me configure it. Okay, sorry, DNS server. It should also be an IPv6 address. Okay, so let me configure 2001 : let me configure it. Okay, it is an IPv6 address only. Okay, this is what I have configured. Okay, coming back to that interface. On that interface, I'll configure IP DHCP server, IPv6 DHCP server, and the name of the pool. So pool was this stateless. That's what I configured. Okay, so run interface.
Stateless is just a name or it is
just a name. It can be anything. No, it's just a name. It can be anything. ABC, XYZ, whatever. And within that pool, section IPv6 TCP. So within that pool, I'm just configuring a DNS server, nothing else. Okay, and I have declared that this interface will be giving this DNS server IP to my client. Let me just make it no shut. Interface E0 by 1, no shut. On this R2 router also, if you make E0 by 0, no shut. Interface has come up. Okay. Now if you check show IPv6 interface E0 by 0. Okay. Let us see. This is the subnet information that you got from your autoconfig mode. Stateless address autoconfig enabled. Okay. Your global unicast address is from your upstream router. You got this as a subnet, from which it derived its own IP address using the EY64 method, using the MAC address. Same way, that's what I told you. I mean, your initial bits will become this one. Okay, the rest of the things will be calculated from your MAC address, your same MAC address, splitting it into two parts, adding this FFFE in between, and then inverting your 7th bit. Okay, this one. So that's how you are creating your global unicast server. you have not manually defined, but you are getting this IP address via autoconfig. This is known as your stateless address autoconfig. Why it is known as stateless? Because this device UIPv6 DHCP, okay, binding, I'm not maintaining any pool or I'm not maintaining any database for my DHCP bindings. I'm just telling that I'm just sending my subnet information, sorry, towards my client because it is running autoconfig. That's it. I'm not maintaining any binding table. That's why this method is known as stateless. Stateless address autoconfiguration.
But can I find that what IP address gets that client?
No. No. The IPv6 address that client has assigned, yes, you can see logging into this router using show IPv6.
No, from that upper router?
No, upper router has not given any IP address, man. He has
Okay.
only told you that I'm using this subnet. That's it.
Okay.
Okay, he has only given you this range. This subnet has been told to you. That's it. This IP address you have calculated locally, right? Based on your MAC address.
No, like IPv4 address, we can check that lease IP address from there.
No. See, that is also possible. But in this scenario, this is your stateless address auto configuration. Okay.
Then
It is
we
not
should
maintaining
configure
any.
stateful.
Yeah, stateful also I'll show you. Stateful also in this same lab. That's why I have taken these two scenarios. Okay. Firstly, we are configuring stateless. I hope you are able to understand how it is being configured on your client side. You are configuring auto config. Okay. Another thing, let us quickly check. Let me shut down this interfaces. Interface E0 by 0. Shut. Okay. On your DHCPv6 itself, interface E0 by 1. Sorry, E0 by 1. If I remove this command, no IPv6 address. And coming back to R2, let me now do show IPv6 interface E0 by 0. There is no global unicast address configured. Stateless address config is enabled. Hey, admin down, line protocol down. Let me give one more shot. Okay, let us now see show IPv6 interface is 0 by 0. See, you still got your IPv6 address calculated. Okay, the stateless pool that I configured over here that could have been used if I want to dynamically send your DNS information or any other such information, then I can configure. Otherwise, just think like let's say this is your router. Under this, you have a switched environment. Okay, multi-layer architecture. Right. Okay, this is your aggregation switch and then your access switches. There are number of hosts which are connected. Okay, on all those hosts, how will they get the IPv6 address? Let's say you do not want to manage or you do not want to maintain a table that which IPv6 address was allocated to which host. Then in that scenario, you can use this stateless address auto configuration. Okay, here you just need to give auto config. Nothing else need to be defined over here. You just need a IPv6 addressing over here plus your IPv6 unicast routing. that you need. And this router will not maintain any IPv6 address bindings. All right. Any question, guys?
No, sir.
Sir, what is the mean by the stateless in one line?
Stateless means your state or your binding is not being maintained anywhere.
Okay.
Normally in your DHCP server, you maintain a binding table which shows you which device, let's say H1 got this IP address and this is the lease duration. You are maintaining that thing. But here you do not have any binding table being maintained because you are not allocating or you are not sending IPv6 addresses. You are only telling that this is my subnet which I'm using. Correct?
Yeah, correct. So same configuration we can put stateful.
No, stateful. I'll come back.
So,
Okay.
sir,
I'll
the
come
client
to
getting the
stateful in a
IP
minute.
address of same subnet?
Yes, they will get from same subnet. Correct. You will get from same subnet because you are sharing the subnet only. Your IPv6 address that will be calculated will also belong to this subnet. Okay. On this one, the pool that you have configured, if you configure, I can configure a default address. I was checking if we can configure a default route also. Prefix delegation, link address, permission, port. Prefix. Okay. This tool for prefixes. No, this is something else, I believe. No. Okay. So this is our stateless address auto configuration from where we are just receiving that IP address pool information from my upstream device, and based upon that subnet only, I'm calculating or deriving my own IPv6 global unicast address. Okay, why it is known as stateless? Because your and none of your device is maintaining the binding table about this. That's why it is known as stateless. Okay, coming back to our stateful. So we power on this device. So in your stateful configuration, it will be similar to how we had in our IPv4 things. Okay, what we need to do is we will configure a pool over here. Your DHCP pool will be configured. On this interface, you will configure IPv6 address DHCP. Okay, that you will configure over here, and the pool will be configured. And from that pool, your IPv6 address will be allocated. Let us quickly see. Coming back to DHCPv6. If I configure IPv6 DHCP pool, let me give it a name. Okay, this will be a name, stateful _ pool. Okay, here you can configure address. and then prefix. What will be the prefix? Let me configure something different. 2001. Let me configure this one. 1111. 64. Okay, and let us configure some DNS server also. 2001. 234. 234. 1234. Okay, and domain name, let us also give this one, right? So till now you have configured to show run section IPv6 DHCP. So this is the stateful pool that you have configured till now, right? Now on this interface E0 by 0, which is going towards your stateful client, what is the configuration given over here? Nothing I have configured till now. So what I need to configure is interface E0 by 0, IPv6 address. I'll have to configure 2001. Let's say from same range to configured. Colon 1/64. Let us configure this one. Okay. IP DHCP server. IPv6. DHCP server. And you need to specify the pool as well. Okay. Pool that you have configured. This is your stateful underscore pool. Right. Okay. Another thing. There is IPv6. Guys, in case of your IPv4 things, let's say this is your .1 IP address, and it got your .10 IPv4 address. Now, in order to reach any other subnet, I need to send data traffic towards my gateway, right? Which is .1. Now, how to, if you remember in our first class, we studied that to send a frame towards my gateway, I need to know the MAC address of my gateway. How can I get the MAC address of this .1 interface sitting at R1? R1, if R1 needs to send a frame Ethernet, if R1 needs to ARP request, right? So ARP request I'll send to get the MAC address from my IP address, correct? But in case of your IPv6, I do not have a concept of ARP. But definitely you need a MAC address to create that Ethernet frame, right? So the replacement for ARP is your neighbor discovery protocol in case of your IPv6 address. Okay, you should remember that there is no concept of ARP in IPv6. It works on your neighbor discovery protocol, NDP. Okay, so
we are using NDP here for MAC address. Right?
NDP in IPv6 it uses NDP
and
neighbor
IPv4
discovery
for ARP, right?
IPv4, yes, we use ARP.
Okay, then.
Okay, so in here IPv6 ND, you need to set your managed config flag also. This one, host you should use DHCP for address configure. That also you need to configure on your server for your stateful address sort of configuration. Okay, coming back.
So it's NDP or NVD?
NDP, Neighbor Discovery Protocol.
Okay, so what is here? IPv6 NVD?
Where is NVD?
You put the command.
No, I put this one, neighbor discovery. This is the flag I need to set on my DHCP server to tell this that this is your stateful address auto configuration that is being done. Apart from this, I'll also tell that what is the prefix that I want to use. Okay, I want to use from this particular pool, which I configured 2001 : 1111. This is what I configured as a pool, right? Then what is the valid lifetime that I want to configure? Let me make this as something different. Okay, preferred lifetime I can configure. Then one last thing, do not use prefix for auto address auto configuration. I manually want to tell that do not use this prefix for stateless address auto configuration. Okay, these are the three flags. I'll tell you about them. One is your managed config flag. This is M flag. This is your flag or your address stateless address auto configuration flag that you are setting. Okay, basically you want to tell on this particular interface, please use only the managed or the stateful address auto configuration. That's what I have said. Coming back to your R1 device on DHCP, what we have configured so far is 0 by 0. You have configured your IPv6 address. You have configured this one managed config flag so that you are telling that this interface is only being used for stateless address auto configuration. I'm telling everybody that this is the prefix from where we will be configuring IPv6 addresses, and do not use the address auto configuration. And this is the pool that we have configured for this interface. On R1, we need to configure this interface E0 by 0 to acquire an IPv6 address via DHCP server. Okay. Let us see. Config T interface. So host name, let's say R1 E0 by 0 IPv6 address. Okay. Auto config. Right. If I just make it no shut. Come up. Show IPv6 interface E0 by 0. Okay. Stateless address auto config enabled. This is by default enabled. That's why on your server itself we have given no auto config. So IPv6 is enabled.
The server side E0 0 is shutdown mode. Mode is shut down.
Oh, okay, yes, you are right. Thank you so much. No shut. Okay, coming to R1. Let us see. We could have captured the packets also E0 by 0. Missing. R1 is 0 by 0. IPv6 address auto config. Okay, IPv6. I think this is enabled. This should make any difference. So then include IPv6. IPv6 unicast routing, that is necessary. Stateful pool. This is we have configured. Okay. So run session IPv6 DHCP. Pool we have configured. Address that we have defined DNS server is okay. Then under that interface, you have configured this IPv6 address. We have configured this server stateful pool. Okay, neighbor discovery prefix that we have defined. Yes, it is configured. We are not seeing any messages. So, please don't raise that up on R1 also. This one raise it up. Yes. Six. Debug IPv6 DHCP on our device. If we check show IPv6 DHCP interface is 0 by 0. It is as of now not showing anything. Here also we are not getting any messages. We just shut this interface. We are not receiving any packet. This is the configuration IPv6 DHCP server. We have that configuration. We need to define this. This we defined on our interface. IPv6 DHCP server stateful pool, yes. Show IPv6 DHCP pool stateful pool address allocation. This one. DNS server is one. Active plans 0. Okay. Let's try this one. Shut this device and try it again. Export config. Export. No. Should have shown. Not even showing any packets being sent between R1 and R2. Sorry, R1 and DHCP server. IPv6 interface 0. IPv6 interface 0. Link is up. IPv6 DHCP pool active now 70. But IPv6 DHCP interface not showing anything. Let me do one thing. Let us configure IPv4 address between them and see if they are able to communicate. Interface E050 IP address 10.1.12.1 0. Okay, coming to your DHCP server interface E050 IP address 10.1.12.2 12.1. Yes, they are reachable. So IPv6 interface E050. This is your link local address. Connect to R1. So IPv6 interface E050. They are reachable over IPv6. Then why it is not generating your DHCP packets? Oh my bad. It should not be auto config, it should be DHCP. Sorry guys, this is my fault. IPv6 address, it should be via DHCP. Right. So your stateful address auto configuration, it requires your client to be configured as a DHCP client, not as a address auto config. Address auto config means you are requesting for your stateless address auto configuration, but DHCP tells that I need a stateful. Okay, and now if you check show IPv6 interface E050, can you see this global unicast address that you have got? So you can see this is not matching with your MAC address now, because this is being dynamically allocated from your DHCP server. Okay. You can see like this show IPv6 DHCP interface. It will show you this E050. It is running as a DHCP client mode. Okay. And this is the address that I have got. All right. DNS server information I got, domain name information I got from my DHCP server. Coming back to your DHCP server, here how we can check is show IPv6 DHCP bindings. You can check, okay, for this client, okay, whose link local address is this one. I have allocated this IPv6 address. This is the lifetime, okay, preferred lifetime, valid lifetime, and that's where it is going to expire. Okay, coming to your these messages. This is the one. Another one. Okay, you could see for your DHCPv4. Wait, I'll close this one. Wait, not to confuse. So this one. If you check this one, there should be somewhere DHCP messages. DHCPv6. Yeah. This only messages. Okay. So, it is not showing. I don't know why. I think we missed those messages. But coming back to our topology here, I mean this R1 router, it is acting as a stateful client, and R2 was acting as a stateless. For stateless, you configured it this as a auto config, but here you configured as IP address and DHCP. Okay, for stateful, it will be maintaining all your bindings. For stateless, it is not maintaining any of the bindings. That's the difference. Okay, the commands to check on your device, you need this IPv6 unicast routing. At least on your server, definitely you require this one. Okay, show IPv6 interface. That's how you can check what is my. It is exactly similar to your IPv4. There you were using your show IP interface. Here you are using show IPv6 interface. Okay, so that's how you can get stateful. Yeah, this is the one where you are configuring this pool and you are applying that pool onto a particular interface on your server side. On your client side, you are configuring it with the IP address, IPv6 address DHCP on the interface. Okay. Stateless also we have configured. This flags I'll cover in our tomorrow's class, and these messages. Yes. All right. Does anybody have any question before we conclude for today?
So from the exam point of view, what kind of questions can we expect in, let's say, IPv4 or DHCP?
Yeah. So from exam point of view, you should be aware, for example, if I talk about DHCP IPv version 4. So you should be aware about all those 4 messages. Who
Dora.
is sending which message? Dora. Okay. From Dora, you should be aware server is sending you offer and your acknowledgement message. Your client is sending discover and your request message. Are they being broadcasted? Are they being unicasted? If my server is not lying on your local broadcast domain, that's where you will require DHCP relay. What is the function of DHCP relay? Okay, some of your commands you should be aware. If I show you this one, this was our curriculum. In your DHCP is over here. Okay, so you should be able to troubleshoot. Okay, so troubleshoot covers your configuration as well as your show commands. So one can configure when he knows the concept, correct? He knows the configuration thing. So you should be aware about the configuration. You should be aware about the concept. Second thing, to troubleshoot, you should be aware about what kind of show commands I should check. Okay, and what's the meaning of the things that are being shown over here. For example, you are firing this command, show IPv6 DHCP binding. So what is the purpose of this command? The purpose is you can see the bindings, which client is getting which IP address. for how much time, what is the valid lifetime over there, correct? So that's how you can troubleshoot. But in your exam or in your certification paper, you won't get any CLI console to log in. You may be, I mean, it may be given that this output is given to you, and he may be asking something like how many clients have been assigned an IPv6 address. Some question based upon your scenario based. I mean, this is given to you. You will not be given to a CLI prompt to troubleshoot. No, but based upon your understanding, like from a list of the, let's say they have given 4 commands. Okay, show IPv6 interface brief, show IPv6 interface, show IPv6 binding, DHCP binding. Out of these 4, which command you can use to see how many
Allocations.
client devices have got allocations? Such kind of question you may get. And if you go through some of these questions, do I know this already? So sample questions have been covered over here also. Okay, for example, this one. You can easily find out what is the correct order of operation for DHCP for IPv4. So if you are aware that Dora is a process, you can easily identify this is the correct answer, not the other ones. Right?
Okay.
Right. Another is which command is needed for on a router interface to forward your DHCP discover message to a DHCP server on a different subnet. Now, if you don't know the concept that where my DHCP relay is being used and how to configure it, then you will not be aware about that this is the command I need to configure or make my router as a DHCP relay agent. Okay. So I would encourage each one of you to go through these do I already know questions, so as you will be able to understand, okay, these kind of questions I may be asked, and that's how I need to prepare.
And the answers are there at the bottom of the quiz? Or
Yeah, answers will be there at the end somewhere over here. This is an answers to the do I know this already. Answers are given. You can verify also.
Okay. Yeah, please. I've already spoken WhatsApp the guy whom I was talking to from networking.
I'll notify them.
Yeah,
No
so
worries.
if you can do it before the tomorrow's class. And about the presentation, is that something that you'll be able to share, or the PPT that you're using?
That more or less it is from the same stuff, but I think actually this is not for NRC. This I won't be able to definitely these recordings will be with you.
Okay. Now, actually, I was thinking if there can be some notes that can be made, because let's say for Encore class, right? There are notes that are prepared so that, let's say, in case we want to just revise, we can definitely see the recordings, but we don't want to see 2 hours to know what's just the recollect.
I agree.
So if we can have make some notes during the class,
I would encourage Ram. Yeah, I would encourage Ram, prepare your own notes.
No, that's something that
has its own.
That's something that I do. But if it's something that can be done online, right? Like for example, in Encore, I think Ajay is doing it actually. So I was just thinking it's uniform across all the classes. I'm just
it's not. I mean, it depends on the style of the trainer, how he's trying to teach.
Yeah.
Because I use mix of all the things, whiteboarding, PPT, and this book also. Because I know which part is given better where, so I mix all them together in order to tell you the best things.
Okay.
But one thing I can tell you, this book is very good. Please follow this one.
Yeah, but like my question, my point is one day before the exam, right? I definitely do not want to go through 1100 pages. So I definitely want to go through something like 50 pages a day before the exam, because I might know the concepts. I just want to refresh my mind. Okay, yeah, these are the concepts we studied, and probably these are the 5 things that I should be knowing in DHCP or IPv6. So in that way, I think that's why I thought the PPT could be helpful. If I don't know if you don't have anything proprietary stuff there.
PPT, no, I don't have anything being prepared.
No, I'm saying whatever you're showing, would you be able to just put that under the resource section?
I won't be able to. Sorry to say, but actually this is not from NRC. This was something, I mean, different things I have captured from other courses or trainings. So it will be too difficult for me to capture them out and whatever things I have shown to you over here.
Can I get this book?
Yes, I'll notify them. You will get this book. No
And
worries.
you're saying that you won't be able to make notes as well, something that we can go through very similar to what
Yeah,
someone else.
you need to
doing.
prepare it yourself, man.
Okay. Okay.
Sir,
Thank
is there any
Thank-
WhatsApp group available in this?
Sir, I have also asking the same. Is there any WhatsApp group?
You need to check with the counselors. Is there any other question before we conclude?
And class timing, sir? No.
Class timings will remain same. We'll start at 10 a.m. sharp. Please join at
Saturday.
time only.
Saturday, Sunday.
Saturday, Sunday, yes. Saturday, Sunday.
Okay.
All right. Thank
Okay.
you, guys. Thank you so much.
One more question.
Thank you, sir.
Hello.
Yes, please.
I'm seeing two. That means second class at start will at 12:30 a.m. to 2:30 a.m. This
Your voice is breaking. Can you repeat?
okay. The class is ended right for today. There is no continuity. The continuity
class-
class will be tomorrow.
Yes, will be tomorrow. Correct.
Okay. Thank you.
All right. Thank you, guys. Thank you. Let's connect tomorrow.